find the path from which we strayed. To destinations far and wide, electric streets and railway lines, a line of stations to guide us home. Beneath the metal towers, machines of a radiant design bear silent witness to a golden age. Glowing wireless light the night, and so we tuned ourselves away to the lonely songs of satellites. Voices from distant cities tell of empires conquered in our minds, and heroes of the world to come. Take me back before the years, before the colors start to fade. Fraction of a grain of time is all I need, so you might understand. I would not falter, I wouldn't hesitate. The generators never rest, turbines drive the onward march of time, onward and forward to another day. Engines of a forgotten time, electric streets and city lights, to the highways that will guide us home. Signal towers, machines of intricate design bear silent witness to the golden age. Glowing wireless light the night, and so we tuned ourselves away to the lonely songs of satellites. Voices from distant cities tell of empires conquered in our minds, and heroes of the world to come. Take me back before the years, before the colors start to fade. Before the colors start to fade.
Good evening and welcome to Shenzhen I, where I'm going to go backwards in time slightly to the custom specifications not unpuzzle where when we were back in Shenzhen we were given access to the spec editor for editing your own, for designing your own Shenzhen I puzzles. And it turns out that when you select the spec editor, actually you get well, if you actually want to edit the spec, you get dropped into a text editor with a Lua file which you can edit in order to try to design your specification. And partly because I haven't got OBS set up usefully for that, and partly because it would have been really tedious to watch, I decided not to attempt to do that on the stream. But after 2 abortive attempts where I discovered what things don't make good Shenzhen I puzzles, I came up with this one. So the idea of this is that we're building a driver for a very simple printer to maybe attach to a calculator or something. And it's a daisy wheel printer, which means it has a wheel with each of the possible characters that it can print on it, and it can rotate that wheel in both directions and fire a hammer to print whatever character on the wheel is underneath the hammer. And it also has motors to move the carriage left and right, and a motor to advance the paper. And the idea is that this printer unit gets given numbers, and it formats them in decimal, right justified, with a minus sign as appropriate, and prints them, and does so efficiently. Though Simon did point out, and I had already worked this out for myself, that of course I could arrange to have it print alternate lines in opposite directions, but that felt like it was probably going a bit far. So here is the specification that I've written, and I'm not sure any of the in-game specifications have required going onto a second page, but mine did, at least. To be fair, I have not worded the specification very carefully, because I'm the only person who's going to read it, and I wrote it. The much trickier bit is writing the test cases, or rather what you write is a test case generator. A small piece of code that that uses the random number generator to generate a test case, and because the game reseeds the random number generator differently for each test run, that gets you the 80 or so test runs that you need to fully test a design. Actually, I did have a worry about my test case generator. I'm just going to quickly nip out into my editor and see if I've screwed this up. No, I haven't. That is fine, right. I was slightly worried that it might actually might not generate 0 as often as it was meant to, but I think it's fine. Because one of the tricky things, of course, is that for the numbers that it prints, if I just had it generate a number uniformly between minus 999 and plus 999, it would be quite unlikely to ever generate 0, and 0 is a special case, because if you implement things in the naive way, you might end up printing 0 as the empty string, which is of course incorrect. So the distribution is actually the kind of logarithmic, in that it first uniformly generates the number of digits that it should output, and then actually doesn't quite generate a number of that many digits. It generates a number of at most that many digits. So, like, if it chooses to generate a 3-digit number, it might actually generate a 1 or 2 or 0-digit number. But this gives it some chance of generating numbers of different lengths, as we can see in the first 4 test cases it generates. The one thing you don't get in the custom specs is the little visualization here of what your device is doing, which would have been really nice for this, because the ability to have it actually print things and show you what ludicrous things you were printing would have been helpful. But I'm afraid we don't get that. I mean, that would be really entertaining to implement in Lua anyway. Or possibly you do, but they haven't documented it. So, there's my challenge, which I've set myself. I've made the circuit board as big as I can, because I really have no idea how much space it's going to need, and it would be embarrassing to determine that that I can't fit it all in.
Here it does seem to say wheel hammer carnage.
That says carriage. No, it's carriage. Look, there's a little dot over the I there. Then it wouldn't be carnage, it would be carnage. Right, so how do we do this then? So yes, and there's a lot of, you're expected to overlap all of the movements so as to minimise the amount of time it takes to print everything. So for instance here, we are both rotating the wheel anti-clockwise. I don't know which direction the wheel goes, and we're also moving the carriage forward too, so that we can print the minus at the moment when we land there, and then we move the carriage, but it takes a little longer to move the wheel from minus to 0 to 1 in order to print the 1, and then line feed, carriage return. So we have 4 simple outputs. Of those, 2, infuriatingly, I say this as the person who laid out the board, who decided what order these contacts go in, those 2 are 0 or 100, and those 2 are 0, 50 or 100. So those 2 can be driven by an IO expander, and those 2 can't. Well done, Ben. But it felt like the logical order was rotate the wheel, strike the correct letter with the hammer, advance the carriage, and then possibly line feed. So that felt like the right order to have them in. So maybe we'll need that. So it kind of feels to me like we might do something that involves that, and then wiring those 2 up. Then if we're feeling really optimistic, maybe we can build it out of just one processor. Doubt it.
That's what I expected it to say. Because normally she doesn't see the time, because it's off the screen. She thinks this is every so anyway.
So that's the obvious first 2 instructions, because we're going to have to because we're clearly going to have to look at this number more than once. So, I mean, do we have... It feels to me like probably actually the first processor does formatting into decimal. Or something. So spaces always come at the start of the number, don't they? So what we really have is advance this many characters, this many positions before printing. Oh, maybe what we send is, if we have the first processor send something like for each character that has to be printed, advance this many and then print this character, or rather, and simultaneously select and print this character. Then we can have. We probably actually want a processor whose main job is remember what position the daisy wheel is in, and given an indication of what character to print, rotate the wheel to the position for that character. Oh yes, a requirement is you must rotate the wheel in both directions, in whichever direction is shortest. Conveniently, because the wheel has 11 positions, that's always unambiguous. Because it has 0 to 9 and a minus sign. So then, like, we could do... I mean, we can obviously do a kind of, is the accumulator positive, negative, or 0? And then if it's negative, we know that the first character must be... It's kind of tricky. If it's negative, then we know the first character must be a minus sign. But we don't know which character that is. But if we were doing this by sending a distance to move the print head and a position for the daisy wheel, then that doesn't really matter, because we work out the distance to move the print head and print a minus wherever that is, and then we start printing the number itself. The alternative is that we remember the distance we have to move the print head, and then add 1 to that. That feels like we want the movement distance in the accumulator, but that's kind of tricky, because we also, if we're going to be extracting individual digits, which we are, we really want the number we're working on to be in the accumulator. But if we're going to extract individual digits, actually we're going to have to copy it into the accumulator from somewhere else, because the DGT instruction corrupts the accumulator, or rather, it destroys its input. So actually, let's start with that being, move that into DAT. Because we're not actually ever going to do arithmetic on the number itself. As in, we're never going to change it. And maybe sorting out the sign happens a bit later. So how do we work out how many... We don't get the maths coprocessor in this world, do we? No. Because we want to, like, count leading zeros on DAT. I mean, we can do that as a bunch of comparisons. We can do that by... we can do that, I suppose, by reading out the... Maybe we do have the first step simply be produce an incorrectly formatted number, like minus 0001. No, minus 001 for minus 1. And then have something later fix it up by detecting those leading zeros and suppressing them. Quite like that approach, actually. Because then that would... So the problem is that if we want to extract the digits in turn, we can't really have a counter for the digit that we're extracting and extract the digits, because any counter would be in the accumulator, and we have to corrupt the accumulator every time we extract a digit. So rather bizarrely, if we actually wanted to do this without having 3 separate DGT instructions, we'd have to do that with a second processor that just handles counting digits, which is probably a bit silly. So what happens if we decide that this processor's job is just mov dat ac dgt 2 mov ac x3, say dgt1, oh no, mov dat ac dgt1, excuse me, mov ac x3 mov dat ac dgt0 x3. I've not bothered with working out how negatives work, partly because I really want to know how DGT handles negative numbers. So at that point our idea is actually that doesn't do all of our thinking by quite some way. Instead it just sits down there and, well, actually let's just write whatever it emits into RAM. So that regenerates 081. That one generates 00 minus 1. And these obviously do what you expect. So I think, and actually this appears in the release notes, that DGT copies the sign into every digit it extracts. Which is kind of interesting. And like, we can see if the next step can cope with that, and if not, we'll it's actually absolute value is slightly inconvenient to achieve here, so that's like it's a test and a conditional multiplier, I suppose, and we can, the test obviously would apply to the entire number. So it would add 3 instructions to remove the sign bit from 2 of the digits we output. So yes, that's doing what it does. And works correctly. So then we could have something that did something like so the idea here is we're counting leading zeros, and if we get a leading zero, we don't treat that as a character, and we keep counting leading zeros. Now there's a slight problem there, that of course if all the digits are 0, we don't want to emit, we don't want this loop to end up just jamming at the end. That's fine. So what we instead do is say we want this to be an yeah, that's right. If dat was 0, but ac, which we're using to count characters, has reached 2, i.e. we have skipped the first 2 digits. I'm gratuitously not supporting negative numbers here, aren't I? Which we should fix, but maybe not right now. Let's mov 1 ac, so that ac starts off skipping the first character, because that's where the minus sign would be, but we're going to pretend we don't understand minus signs for now. So now if we run out of this loop, either then ac represents the number of leading spaces, hand-waving minus signs, at the start of the number, and dat contains the first non-space character in the number, and we are going to receive further characters over x1, so then if we assume that the job of the next do we attempt to do this in parallel? So the tricky thing now is that this processor and indeed this one may have to wait for the actual output processor to do things unless we have a buffer, and so yeah, that would get quite complicated. Maybe these two, the early processors between them, fill up a RAM with a sequence of instructions for the output subsystem, and then the output subsystem executes them. That seems quite a good plan. So that then copies the number of initial spaces into the RAM. And then we copy the first digit into the RAM. And then if that was the last digit, let's increment ac now actually. If that was the last digit, we do something. If it wasn't, then we repeatedly copy, say, advance 1 space. This is not going to fit. Print the next character. And then advance to the next digit. Now what we're lacking here is that we don't do anything to signal that we've finished printing the number, which is a nuisance. and yet we've already run out of code space in this processor. Though if it were the thing... maybe we shift things around a bit. I'm now wondering if we do something like the first thing formats the number very badly in the RAM, and then the later processors poke around in the RAM and update it until eventually some processor can read out something that's correctly formatted. So the first thing writes like something to indicate plus or minus, followed by 3 digits, and then the next one like handles moving the plus and the minus sign to the right place and blanking out things, and then something else prints from it. Rather than passing things on to along the chain, they instead each just edit what's in the RAM, and that has the slightly pleasant feature that they can all take advantage of the fact that you can trivially find out what you're currently looking at in the RAM and what position you're currently looking at without needing to carefully count things. Which, like, would in particular make this code simpler because it wouldn't have those two add ones in there, because you would just end up comparing the RAM. The thing is, this one's trying to do so much that the RAM locations are no longer helpful. But then that would suggest that the last stage would have to be able to construct automatically the move n spaces and then print the first character. So that may not be so hard, because it essentially loops through the RAM to find the first non-space character and then reads out the address pointer from the RAM at that point and uses that to generate the offset. And uses that to generate the length of the carriage pulse. Do we have to... do we actually separate carriage and wheel drive into two separate processors? Because that would make the working out the maximum a little simpler. Or would it? So... actually, let's do this fairly densely. that worked like that instead. Oh, except it does actually need... Oh, but backspacing the RAM's irritatingly confusing, isn't it? Because that's like 3 instructions. We've done this. Whereas if it's a pipeline, it's not so... Yeah, okay, let's scrap that idea because editing the RAM's difficult. But I think we go back to the plan of and then I like the idea actually now of not trying of sending just character code. So we'll say that 0 to 9 as outputs represent the digits 0 to 9. Let's say minus 999 represents space, because it's traditional as the exception character. So that now, let's do the trick we did before. Why are you mobbing 0 to x3? Oh, that was still when I thought I had a RAM there, wasn't it? That didn't work right. So that one ended up blocked on read. So let me see what happened. Started out fine. Oh, I think my boundary condition is just screwed. Yes. So, let's gratuitously go. Right. So let's go for a simple rule. ACK is always incremented just after you emit the character. Then I'll get the boundary conditions right in a moment. Right. So that now correctly writes things into the RAM, except that it doesn't understand minus signs. I mean, the RAM here is essentially acting as a convenient infinite sink. Okay, that wasn't correct. What? Why have you gone wrong? What? On my third number, you write out 90 rather than 990. Amusing. I mean, I don't ever seem to have a jump Z, which is kind of critical to this. Which surely meant that it actually screwed up quite early. Because it did the wrong thing here. In that it should not have written minus 999 minus 9990 minus 1. It should have written space minus 1. Which is still wrong, because the correct output would of course have been space minus 1, but we haven't even decided how we're encoding minus signs, so okay, so what happens here then? So that's a bug, but I don't know if it's this bug. That then sends 9. Oh yes, what? We never actually... Yeah, this loop's completely mad. So first, that obviously wants a plus jump Z to keep searching for leading zeros. And then if we've decided that what we've got isn't a leading 0, it's still sitting there in DAT, and we need to actually write it. Damn it, we filled up this processor again. And now that's jammed there. That's interesting. So that's now wrong as well, because it ends up with 1 0 too many. Yeah, I think I'm trying to be a bit too clever here. So we go, is the current digit 0? If it is not... So if the current digit, if it is not, then have we reached 3? If not, why is there not a minus on that line? That's obviously wrong. Right, let's try that. Better, that's written the correct thing for the first number, and then written far too many minus 999s for the second one. So given our sign support is not yet working properly, which does make me worry a bit about how much code we're going to need in this middle processor, we should write this out as more or less space, space, space 1 or minus 1. Yes. That probably just means I've got that. So the problem now... Hang on. What? No, that's completely wrong, Harris. That's never going to work. Because now if we actually run out of digits, like we reach the last digit, which always has to be printed, then we shouldn't... What? I've got these conditions completely backwards.
Yes, they have a logic lesson why printers never behave as you expect.
Yes. So, yes, I've got that. These conditions are utterly wrong. So what it wants to do is print a space only if dat is 0 and ac is less than 3, and we can actually less than 4 actually, I think. We can actually perfectly well make that a positive question, which makes things a lot simpler, right? Let's just do advanced. So that wrote the correct thing. That's the correct thing now. That's correct. And that's correct. So that's now able to correctly format positive numbers and only slightly screw up negative numbers. But we've run out of code space for having it... I mean, that's slightly unfair, but we've run out of code space for having it emit minus signs and any signal that the next processor in the chain can do something. But or rather any signal that the next processor should carries return, but that's fine because this is outputting a fixed number of digits, so possibly the next processor can handle the counting if it has to. On the other hand, this one does know what the counting's doing, so if it can do it, it might be easiest for it to, but we don't currently have any space. We've got 2 instructions we get to delete in order to put, or rather 1 instruction we can delete in order to put the minus sign support in, which seems a little optimistic. And in particular, given the way this is currently working, only... but we could of course have this one do the minus sign at the beginning. And... yeah. I was going to say, and have this one remember it, but it doesn't actually get to see it very... doesn't get to... We actually want it pretty much at the moment we see the first non-zero digit, except that we need to put the minus sign just before we see that digit. in that if we read, say, -1, that comes out as 0, 0, -1, and we want to replace the space that we would put that 0 in for that second 0 with the minus sign. So so we do really want to see it earlier. So it'd be easy enough for this thing to spend an extra couple of instructions extracting the sign bit from the number and transmitting that.
It's not a bit, it's just a sign.
Yes. Extracting the sign from the number and transmitting that. But then the tricky thing is that this processor really, ideally, emits that as the last leading, in place of the last and only the last leading 0. But that means it has to save leading zeros and transmit them slightly later.
Yes, I mean, when you aren't under these constraints, the obvious way to generate this kind of output is backwards. You generate the units digit and work gradually up, and when you run out of digits, you say, oh, well, this is the point where I hit the sign bit, and then you read the whole thing out in the opposite order to actually do it. You mentioned backing up in the round is tricky, so maybe that's not...
Yes, yes. Well, I mean, in a particularly perverse way, this is an occasion when you want to be programming TIS-100, where the RAM is a stack. Or rather, you can have stack memory nodes, which you leave, which you can put data into, as long as you don't mind the fact that it comes out backwards. But the RAM in the MC4000, MC6000 environment is sensible, and hence always reads forwards.
So you can't find the word?
Yes. So yeah, backing it up is kind of inconvenient. What if we change it so that what this outputs is instead back to what we originally wanted to do, except that what it outputs is number of leading spaces followed by printed characters. Because that's probably the kind of thing that the next stage wants. So, if thus...
Sorry.
So then we would So the first non-zero digit is obviously guaranteed to be non-zero and hence to have a useful sign.
I mean, you could have an entirely separate process whose job is to count digits.
Yes.
The idea of using a processor as a subroutine, in fact.
Yeah, I mean, we...
0.2x buses of one processor at a sub-processor, and every so often you just chuck in a thing and immediately...
Yes, I have done that. You only need to use one X bus because they're bidirectional. So we could have like so a better way to do this. But let me finish this off first. Now then we need two instructions just to step backwards and there to reduce the count of leading spaces and then to emit a minus sign, which is kind of unpleasant. But yes, we could. So what would we actually want as... So if this, so you know, like the first step here, I quite like this. This processor is proving quite unwieldy. So as far as this one is concerned, the awkward thing is that by the time it knows what sign bit it wants... Ooh, maybe that's the answer. I think I'm going to wipe this out and start again simply because trying to edit it is a bit painful.
Confusing stuff.
This is modified.
Damn it. And I still need to jump D in there. So the idea here was that we output the leading spaces, except for the last leading space. Then we either output minus sign or a space, having just received the first non-zero digit and thus being able to see the sign of the number. Then we output that leading digit. Then we output the rest of the digits. And that all seemed lovely, except that it turns out to be one instruction longer than I want.
Mute people listening online.
So I suppose the question is, can I play silly buggers with a TCP to get that zero, where I need to go 3 different ways depending on whether something is 0, positive or negative. But as is usually the case, 0, the equal case, is the special one. And I have a bunch of instructions I want to execute only in the equal case, which is the one case you can't only. So then if we did that, so like that's really simple and probably works correctly, except that last loop doesn't work properly, doesn't happen properly. Let's just check that it does behave sensibly in all other respects. So it goes leading space representing the sign, first digit, second digit, oh bum. I mean, actually it works fine for a 2-digit number, because that last loop only has to execute once in that case. It's kind of interesting that loop executes... Oh! That loop executes 0, 1 or 2 times. Yeah. Wondering if I could use a TCP for that, but I can't, because I could use TCP to say, do we want to execute 0, 1 or 2 times, but then the 1 time, but then I can't make the 0 and 1 work correctly, because I need an instruction that I execute that I don't execute when there's a minus flag and do execute when there's no flag. TCP is so very often not quite the instruction you wanted. So that kind of works, but also kind of doesn't. So what if instead we started off with TCP DAT 0. Now this is difficult because the 2 cases we first have to deal with, therefore, are plus, which means we have reached a non-zero digit and it needs to be and thus we need to copy a space into the output. There's also a question of how we encode, oh, don't worry about that, minus signs and such like, which I've done as -1, but that's obviously not helpful, because we also encode the digit 1 as -1 if the input was negative. Make it -100 for now. And then we want a if plus or minus, which you can't do. can't actually do that with dat anyway. That's obviously wrong. And we can't have an unconditional... Yeah, we want... So then the problem is that we end up with like a plus jump thing, minus jump same thing, just so that we can do the rest of the loop. No, that really doesn't work. So back to that one. Still can't see how to do this better. So that feels like we may have to reduce the amount of functionality that goes into this processor. Right, how could we reasonably do that? So it feels like, so we've got a kind of messiness with that minus sign bit. I'm going to change that number so that it's distinct. So can we do this by some better means? Can we have this handle leading zeros, something else handle the minus sign, and assembling the whole lot again? So if we had this processor send a signal about the minus sign to another one, and that one then dealt with the talked to the leading zero suppression processor and inserted the minus sign in the right place. That might work. Okay, so let's simplify this so that let's take it back to a version that doesn't that just handles leading zero suppression. So in particular that means it doesn't do that bit. It does do that bit. And it doesn't worry about fixing up the sign of the output, because something else will fix up the sign of the output later. And obviously I've screwed it up somehow. I'm missing an add one somewhere. I am. Still wrong. And that obviously now wants to be 3. So x starts as 0. We increment it when we write the minus 999. We can do that, but obviously that's stupid because there's no need for that add. Let's just reduce that by 1. So that's now just generating the 3 digits, possibly with the sign wrong, with leading zeros suppressed. So then let's have another processor actually, how can we shuffle this around elegantly? Probably has to be a big one, doesn't it? I bet it's going to turn out we can't do that otherwise. That then goes, so then this one writes, does
Details.
what on earth? What do you want? What do you don't mean x0, you mean x2. And then this one can then go but it needs to spot the last minus 999. No, that's not a problem. It doesn't. It spots the first non-minus 999. So, and indeed, all digits. So, then we can go oh, this is somewhat cute. No, because then we run out of condition. We corrupt the condition codes. That's fine. This thing doesn't send -1 and +1. It sends whatever the space character is. Sorry, whatever the minus sign character is, which we'll pretend is but we'll pretend is -100 for now, though that's obviously stupid, and it sends the space character. So then this then goes, if you read something that's not -999, then write the sign character to your output, and then does this work? And then blank the sign character, No, that's not quite right. If you read a non-space and the sign character is not blanked, is not 0, then all of my tests here being in negative logic, then transmit the sign character. And then more generally transmit the character you just received. And then our only problem now is that we don't have any counting in this bit, in this processor, to handle what a carriage return looks like, because we've run out of registers to do any counting in. We have actually got one spare instruction here that could transmit an end of line sentinel. And then this one could do like TDAT 999 minus jump S. Oh, that one needs an SLXX one at the beginning as well. Actually, sorry, advanced, let's see what happens. Well, that's not correct. And it's ended up hanging. What am I doing there? What on earth is that code playing at? Like, be sensible. I'm using DAT for two different purposes and I'm confused by the fact that it's not working properly. Right, that'll work a bit better, maybe. So that now writes into here, space 8-1 carriage return and line feed. No, they're not separate characters. Space minus sign -1, I should fix that, CRLF. Right, so this one should also, in particular because it's got a bit of space, do a TLT at 0 if AC is less than 0, mul -1. That's not right. Let's just check that that fails in the way I expect it to fail and then decide how I'm going to fix it. Okay, it doesn't fail in the way I expect it to fail. What? I've only... Oh, that... No, that's fine. What? So does it work in that state? Yes. What? Why? Why does that mul -1? Oh, because that converts a -999 into a +999, which was the little bug that I thought would not be a serious issue, except that we're using 999 as a sentinel value.
Every time you think that.
You think that I could leave that bug and fix it later. No, it turns out that because my sentinel value is minus space, if I corrupt space into minus space, I break my sentinel value. Right. Okay, in that case, let's...
Minus space is clearly some kind of strange concept from a science fiction universe.
Let's make my sentinel value positive and my space value positive and make them distinct. Is that reasonable? It'll do. Oh yes, we actually need to include the no, that's still crashing. Oh, because I changed the sentinel value, and therefore that needs to say 999, and that needs to say 998. Right, so now that writes space 81 CRLF. And that writes space -1 CRLF. And that writes space 990 CRLF. And that's rather boring and writes space 969 CRLF. So that is now emitting a possibly sensible sequence of characteroids, of which the last one is always a CRLF character. So then we could have another processor that handles converting those into wheel rotations and maybe carriage movements. Right. I kind of feel we need to start condensing the physical layout of the board a bit. So in particular, that processor should obviously go over here. That gives us a bit more space to play with. So, we should almost certainly change the encoding of minus sign. So we probably want to encode wheel positions as numbers, and minus sign appears after 9 or possibly before 0. Obviously encoding it as 11 is more, or rather as 10 is more sensible than encoding it as -1. Well, probably. So let's change the encoding of minus sign to 10. And check that that still works. What? Okay, how does it turn out that changing the encoding of minus sign breaks things? It doesn't. It turns out I've screwed something else up. What? Oh, it turns out that I should wire that up to the data port of the RAM and not the address port of the RAM. I'm not entirely sure how that did anything useful. Okay, that's better. Right. Right, that's better. Right. So now something probably wants to go don't know which register yet. So we want to calculate the movement from where we are to our new destination. Probably doesn't matter if we accidentally invert the sign. Convenient. So we probably, and we're then going to need to remember our new destination. So we don't want to corrupt that, but we don't really care about where we are once we've worked out the movement. So I think that probably means we do something like subdat. So we have ACK contain why am I not allowed to put it off the... I'm allowed to put the post-it note off the top edge of the board, but not off the left edge of the board. How odd. So, yeah, so if we do subdat, that means that the accumulator now contains probably the negation of the movement we want, but that's not really a problem. Our sign convention is pretty arbitrary at this point anyway. So then the issue is that might be outside the range of plus or minus 5 because there are 11 positions on the wheel. So if it's less than -5, we want to add 11, is that right? Yes, so if it's -6, then we want that instead to be converted into +5, and if it's +6, we want to convert that into -5. So that's now made sure that we have in the accumulator the fastest wheel movement that will get us to the right place. this, of course, assumes that all the incoming instructions are wheel movements, but they are not all wheel movements. So we also have carriage movements and the end of line. So the carriage movements, so a space in particular, we end up wanting to fold into the next character somehow. But I think what that means is that we have some intermediate thing that's counting up the number of spaces that we see. So we have this thing which acts as essentially a subroutine that counts up that works out the wheel movements, and we could have another thing that works out the carriage movements, and then something that kind of merges them. I'm now wondering if this processor could actually send the wheel movement characters down one X-bus output, i.e. the printable characters down one X-bus output, and the non-printable characters down a different X-bus output, by which I'd mostly mean the spaces. Though I suppose the same processor could also be responsible for CRNF. And then...
But then the processor that's doing the CRLF has to wait until... has to know when the other one's finished prattling about with the wheel.
Yes.
Which will be very limited time.
Yes, so then the tricky thing is merging these two things. But I think if these two... I think these processors themselves... So we're still at the moment in the situation where there is no time. Everyone is doing their calculations instantaneously. So at some point we have to start buffering. And the design at the moment is that none of this lot ever pauses. So what if we were then to write into the RAM like a sequence of instructions that go these wheel movements and these carriage movements for each character? Or rather, not for each character that gets printed. And then something were to read that. So this thing is basically just handling wheel movement. And in a sense, that is really a subroutine. In that you tell it where you want the wheel to be, and it can send you back how to get there. And then it should then, and that should then go into the RAM alongside any counts of carriage movement. But that means that this thing can't just send... So, but can this... The problem is that, yes, it's quite tricky for this to incorporate the carriage movement into what it thinks about, because it's got no registers spare for that. And someone needs to be counting the leading spaces and counting, and rather more trivially, counting the other spaces and the other movements. And actually, mostly this code spits out every character. But I suppose, how many MOVs into X3 does it have? It has that one and that one. So it could... It's got 2 instructions spare, so it could send every character it thinks about down 2 outputs if it wanted to. And this could like do TGT DAT 900, if so, jump end, and thus though actually we probably need this to detect 998. So if we then say, in the event that what we found, actually it may be easier to do this up here, or maybe not, I don't know. We can then just have that sleep be conditional on whether what we just read was a... I mean, actually, that doesn't matter because SLXX1 will perfectly well work. So now, okay, if we just do... What? This is becoming trivial. Well, no, it's not really. Then we add in there mov ac solid x3. So that would now just emit the wheel movements. So it emits, well, that's wrong. I mean, it got the right number of wheel movements, but 3.2 is definitely incorrect. Okay, why is it always emitting 3.2? Okay, it doesn't always emit 3.2, that's good. So that reads out a space and therefore ignores it. That test is pointless, Harris. It might not. Yes. It then reads a space and ignores it. Wheel is still pointing at 0. Oh, I'm an idiot. Right, yes. There's a rather critical thing here, which is that we also need to remember where the wheel has gone. One, two, three, minus 1, 2, 3, 4. Good. 2, minus 2. Good. 3, 0, minus 2. Five minus 3 plus 3. Right. So this is now correctly writing out the sequence of wheel movements for each character that has to be printed. So then we can have another processor that generates the carriage movements for each printable character, and then some other processor that somehow merges these. I'm sure this will be fine. So let's change the pin assignments a bit. Let's make that use X3 instead of X2. make that write to x2 instead of x3. And make that read from x0 instead of x1. Point of that being that now that XBus port is conveniently accessible and we can wire another processor into it. So that should still do the right thing. Yeah, that's looking good. Right, so carriage control processor. So what does this do? What this does is if its input, stick with mov x1, slux x1, mov x1 dat. Then if dat is space, increment the accumulator. If dat is not space, then output the carriage movement and say and reset the movement perversely to 1 and not 0, because every character other than the first in the line needs to have a one space advance before it. Then we do have to deal with carriage return. We'll probably firstly need to deal with to save this instruction because that teak was doing nothing. Actually, no, that's not right at all. If we receive a CRLF, then set the accumulator to 0. Actually, maybe we do something stupider than that. I think maybe we set it to -1. Then, if it is not... Oh, that doesn't really matter. If it is not 9, then if it's not 998, then take it against 999. Maybe that is what we want. Then if it was not 998, then see if it's 999. If it is either 998 or 999, add 1. If it is neither 998 nor 999, copy it to the output and reset the counter to 1. I appreciate I'm running out of output circuitry here. Let's just drop another RAM in here. So I think, all being well, each of these should then write the same number of bytes to its RAM, one of them with the carriage movements for a printed character, and one with the wheel movements for the same printed character. Okay, that one does nothing at all, because nothing actually sends anything to that processor, because I need to add the 2 instructions that would do so. Right, so that then says the first character requires 2 carriage movement, the second printed character requires 1 carriage movement. That looks good. Similarly, 2, 1. Then this one requires 1, 1, 1. One, 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 and that's it. So that's looking pretty good. Pity we don't have any negative 3-digit numbers here, but if we ignore that fact, I was wondering how I can condense these circuits a bit. These two are now writing out the same number of outputs each. This one detects carriage returns if we need it to output a special sentinel value to say end of line. This one doesn't, but we can fix that. So, one slightly awkward thing is that we currently have 2 RAM chips. We can probably do better than that. But we might have to come up with some kind of synchronization between these two. So if we link them together by an X bus, then one of them could signal to the other that they had finished writing to the RAM, and then the 2 of them could thus write bytes alternately into a single RAM, which would be less horrible. So that, and then we could have something that reads from the RAM and executes all of the instructions therein. And then the only problem is whether we can manage to devise the thing that reads from the RAM and executes the instruction so as to be simple enough. It's kind of difficult to signal by X bus by simple I/O between devices. I'm kind of wondering if there's a sensible way to have separate devices. So the problem here now is that we have to, that the amount of time it takes to print a character is the maximum of the wheel movement and the carriage movement. That may not be so bad. I was going to say it may not be so bad, but if we have a processor that has an accumulator that counts down to indicate time passing, comparing that against two values is kind of inconvenient. Because we don't have somewhere to put two values, we can easily put a one of the movements in one register, but if we have both of them in registers, then that's 3 registers, because we also need the counter. Using gen is kind of tricky. And we don't... Oh! I suppose you could have... Oh, that would work. If we had a timing processor that... If we had a separate wheel output processor and carriage output processor, and then a timing processor that had a single X-bus input that was wired to both of those, wired to X-bus outputs on both wheel and carriage processors, then the wheel and carriage processors could both signal it, and the timing processor could just have 2 SLXs, or SLX MOV X thing into null operations, one reading from each of those output processors, and once both, and it wouldn't care which way round they happened, it would just read both of them. Right. Might work. So, what would the wheel output processor look like? So, it waits for a wheel instruction. And then it probably has to move it to the accumulator. If it's, let's say if it's positive, let's assume that 0 is not difficult. If it's positive, generate a positive, generate a pulse of act length followed. Actually, I think we ended up getting the signs wrong, didn't we? Ever generate a pulse in that case with 0 high and act low. Otherwise, multiply by -1 and generate a pulse of act high and 0 low. Oh, those should have P1 and P1 and the actual instruction. And then MOV 50 P1 MOV null X1 to signal that we've done it. Let's comment that out for now. That, of course, does not work. The reason why that does not work is that X0, it will end up jamming up because this will be trying to write to X0 and that won't be ready for it. Well, that wasn't what I expected. So the wheel calculation processor. Oh, that's the. Oh God, I've got the carriage and the wheel the wrong way round, haven't I? That's the carriage processor, and that's the wheel processor. That's no good. Let's swap those over. Not X0. And then that will end up. Actually, that one ends up blocked writing. Which is fine. Right, so that's more or less reasonable. Except that this really expects to be reading from a RAM buffer or something that's sensibly approximating one. So how about we add... I mean, like, we can have... I kind of wanted my timing process to be able to be connected directly to the hammer. And then it would do something like that. And wait for a signal from this. But then the problem is that this needs some buffering somewhere. And this also needs some buffering, and there's a question of, like, if we have two RAM chips, that's quite a lot of space physically, and we don't really need two. They only need to buffer up to 4 bytes per processor, so 8 in total. But the tricky thing is, if we're only using one RAM, they need to neatly then these two need to interleave their writes, and unless we have something big that handles that RAM and all of the timing and other, like, thinking type activities. doesn't quite work because I want another port on that RAM to be connected to everything. So the need to buffer everything is kind of inconvenient. Oh, for a world in which time wasn't so weird. So my problem here is that if we only use one RAM, then these two have to cooperate over writing to it, and these two have to cooperate. Like, I know that there's an imaginary processor somewhere down here that drives the carriage. These two have to cooperate over reading it. That's kind of inconvenient. So if that were to happen, it would have to be by we'd need these two to signal to one another who should write to the RAM when, and they'd have to have a connection to the RAM. And then this one would read from the RAM, could read from the RAM and hand out data to either of those two, given it's going to need to be connected to them anyway. Though it would need to receive a signal to say, we have written a character into the RAM, please process it. So that would mean it would need an XBus link to the RAM, an XBus link to whichever one of these two did things second, an XBus link to each of those processors, which is the correct number of XBus links if we can fit everything in. So let us start condensing the circuitry a bit. If we were to move this one up, then we could do that, and that, and that. And that would then give us enough space to move this processor left. The only problem being that that wouldn't be able to fit, so that would want to go, well, I mean, we can, if we really have to, do that. So I bet there's a better way. I think I need to start making notes on what everything does now. So Uh, that's the digit processor. That's the sign processor. That's not right. No, that's the leading zeros processor. That's the sign processor. That's the carriage processor. That's the wheel processor. Right, that saves me waste board space on a sticky note. So this one outputs wheel movements, and that one outputs carriage this one outputs carriage movements, and this one outputs wheel movements. And with some synchronization, they could both write to the same RAM. So they would thus each have an X-bus port that connects to the D port on this RAM, the D0 port specifically. And they'd each have an X-bus port connecting to the other one. Obviously that doesn't quite work because actually it's not too bad. The slight problem is that we also really want an X-bus port connecting these two to some other thing. But that's okay, that could be that X3 there. Right, so then this should be changed so that it writes out to X0 rather than X3. This one writes out to X3, and for synchronization purposes we just say doesn't really matter. Let's say that the carriage processor starts with the token. So after it has written, it has to do, it sends the token down X2. Actually, since this is, yes, it doesn't, no, I don't think we even need to model this as a token. There's simply, it then sends down X2 this thing just before writing reads from X2. That one now does nothing. So the idea now is that this should end us up with the RAM elegantly interleaved. So it does end up with 4 values. They go 2, 3, 1, minus 4. They go 2, 2. Carriage processor was all made, yes, 1, minus 2. They go what's it written there then? 1, 3, 1, 0, 1, minus 2. So we probably have to have a sentinel value to say end of print, but that is, I think, writing the correct thing into the RAM. One plus 5, 1 minus 3, 1 plus 3. Right, so that's now writing wheel movement followed by carriage movement, or was it carriage movement followed by wheel movement for each printed character into the RAM. There's no sentinel value at the end, but that will be easy enough to add, I think. And then my idea is that this processor will read something needs to connect up to the feed, paper feed, of course. That will probably be P0 on this processor with some horror. Possibly we swap these processors around in some horrific fashion. We've got a bit of space to play with. A bit. This one then reads values from the RAM and dispatches them to those two. It is only 10 to midnight rather than my usual midnight stopping time, but I do have plans for tomorrow that like involve catching trains and things. So I may stop a little early, partly because this task is quite hard. Hello, Ekin Amble. Good night, Ekin Amble. I mean, looks like I might be able to fit it all in, but it's going to be tricky. So yes, I think what I should do is I should stop now because frankly my head is tired and I want to go to bed. And then we'll be back, if I can remember how this works, on Friday. I think I'm going to blank that. Maybe I should actually scrap everything on this side. And then we can work all of that out on Friday from first principles again. You know, it looks like a nice big space if I wipe it out like that. That way I can vaguely remember what's going on, and then we can write something to dig things out of the RAM and sort out the signalling and so forth later. Right, that will do for tonight. We'll come back on Friday. Good night, everyone.